All right, so we're working on solving systems by substitution here. So this is our second method for solving a system of equations. And again, our goal in the end is to find an XY pair that makes both equations true. Okay, so that's the thing you want to keep in mind as we're working through all these, is that our goal is to find an XY pair that makes both equations true. So we're gonna have three methods here. We did graphing already. Now we're working on substitution, and then we're gonna work on elimination. But in the end, the goal is the same, just to get x comma y that makes both equations true. Okay, you can always solve these using Desmos. I'm gonna want to see some work. We'll take a quiz or test on this, but for the most part, it's the same thing. All right. So in this one, we have y equals 2x and y equals x plus 5. So what we're saying here is, like, if you want to think of y as a dollar bill, y is equal to 4 quarters, and then y is equal to 10 dimes, whatever you want to think of it as, but they're the same value. So what I can do here, I just want to rewrite this because I don't want to mark up the original, is take this 2x and put it in for y in the second equation. All right, because I said that y is equal to 2x. An equal sign means they're the same value. Again, it's like having a dollar bill versus 4 quarters. They look different, but it's the exact same value of money. So that means I'm going to have 2x equals x plus 5. Then I can subtract x, x equals 5. So now that I have x equals 5, I need to figure out y. I can put it back into either original. And you can see here, if I put 5 in for x here, 2 times 5 is 10. If I put 5 in here, 5 plus 5 is 10. I'm just going to put it back in the first one I'm not going to write it out for both, but it doesn't matter. So y equals 10. So my final answer is 5, 10. All right, as I said with graphing, you want to check your answer. And so if you want to go back and check these, we didn't do a whole lot of work for this, so it's not too bad. But in the first one, you have 10 equals 2 times 5. 2 times 5 is 10. You get 10 equals 10. In the second one, you got 10 equals 5 plus 5. And of course, 5 plus 5 is 10, so we get 10 equals 10. That's all we're looking for here, is that both works out in both equations. We're good to go. Again, you don't have to check this. All I need is 5, 10. But there's always opportunities to make mistakes as you're working through these. So you always want to go back and make sure that you're checking your answers. It's take it 30 seconds to check your answer. All right, but it could save you get the problem correct. All right, so the next one's a pretty similar problem to what we just did. We have y equals 4x minus 12 and y equals 6x plus 8. It's the same kind of theme here. We're trying to find an xy pair to make both true. A little bit more work here. But again, it's going to be the same deal. We have y equals 4x minus 12 and y equals 6x plus 8. So again, y and 4x minus 12 are equivalent. We said they're equal to each other. So I can put that 4x minus 12 in for y right there. So I get negative 12 equals 2x plus 8. Again, just be careful here. I subtracted 4x from both sides. Make sure you're dropping down the negative there, the minus 12. We're treating it like a negative 12 now. Subtract 8 from both sides, so I get negative 20 equals 2x. Divide both sides by 2, I get negative 10 is equal to x. All right, so y equals 6x plus 8, so that means I can put negative 10 in for x. So I get y equals negative 52. So you're going to get negative 10, comma, negative 52. So we go back up here. And yeah, I know if I put negative 10 in for x right here, 4 times negative 10 is negative 40, minus 12 is negative 52, so that's good, and we just did the same thing here. 6 times negative 10 is negative 60, plus 8 is negative 52. So it does work in both. You don't always have to write it out, but maybe just punch it in your calculator real quick, make sure everything checks out there. Then our answers works in both equations. So that's one type of problem you're going to come across by using substitution. This is one that would lend itself to graphing. I know this would be way off the graphs that I usually give you, but if y equals 4x minus 12, y equals 6x plus 8. To me personally, I'd rather just solve this by substitution, just set them equal to each other and solve, than to start graphing with the y-intercept and then the slope and see where they intersect at and all that. I like graphing; it's a nice visual, but I would prefer just to do this with substitution. Just quick algebra, get x's on one side, constants on the other, and be done with it, rather than try and go through all the graphing steps. Plus, like I said, you need a pretty big graph. Our y value is negative 52. I usually never give you a graph that big, so this one definitely lends itself to substitution. All right, so next up we have 3x plus 2y equals 9, and then y equals 2x plus 8. So, in this one, the 3x plus 2y equals 9, we could try and solve for one of the variables there, but really it wouldn't work out that great. If you solved for x, you'd have a negative 2/3 y. But the second equation is telling me that y equals 2x plus 8. So going back to thinking that if y is a dollar bill, 2x plus 8 is 4 quarters. Same value, dollar bill versus 4 quarters, the same amount of money. All right, they just look different, and that's what we have here. Y is equal to 2x plus 8. They're the same value, just look different, that's all. So, I just want to rewrite this so that I don't mess up my original. Since I'm telling you that y is equal to 2x plus 8, I can take my 2x plus 8 and put it in for y in my first equation. So that means I'm going to have 3x plus 2. So my first equation's unchanged so far. I'm replacing y with 2x plus 8, and I'm saying it equals 9. All right, so again, first equation, unchanged. I just replaced y with 2x plus 8. That's fine. Everything else stayed the same. The 3x equals 9, all that good stuff. So now we got just a regular equation here. We got x's, solve for x. So now we got to solve this equation. Got to do a little distributive property first. So we got 4x plus 16 equals 9. So it's going to be 7x plus 16 equals 9. Subtract 16. So I get 7x equals negative 7. Divide both sides by 7. X equals negative 1. So we got x equals negative 1. Going back to my originals here, it's definitely easiest to put it back in the second equation because it's telling me that y is equal to 2x plus 8. You could substitute it in the first one. It's just going to be a little bit more work, I think. So y equals 2 times negative 1 plus 8. So y equals negative 2 plus 8. So y equals 6. So for my final answer, like I said before, it's super easy to just go back, substitute in for x and y. You don't even have to write it out like I always do. If you just want to go 3, x is negative 1 plus 2 times 6. We get 9. Look, that took us 10 seconds to do. Just check your answer. Make sure it works in both. Again, 2 times -1 is -2. -2 plus 8 is 6. So it does work in both. So checking your answer, it doesn't always have to be like a super long process, but it's definitely something good to do. Make sure you did all your algebra correctly. Number 4 is kind of going to be the same story here. We got -4x or -5x plus 4y equals 9. And then x equals 4y plus 11. So again, going back to that dollar bill versus 4 quarters, x is like my dollar bill. 4y plus 11 is like my 4 quarters. They look different, but they're equal to each other. I can say that having a dollar bill is equal to having 4 quarters. It's the exact same amount of money. So again, this is x equals 4y plus 11. So I'm going to take 4y plus 11, put it in for x in the first equation. All right, so again, that first equation really didn't change. I still have -5. I replaced x with 4y plus 11, but that's it. Just replace it with 4y plus 11 plus 4y equals 9. So I got an equation with all y's. Just going to solve for y now. So a little distributive property, so -20y minus 55 plus 4y equals 9. I have like terms here. -20 plus 4 is -16. Y minus 55 equals 9. Add 55 to both sides. So now I have -16y equals 64. And then divide both sides by -16. So we get y equals -4. I still got to figure out my x. Again, my second equation was x equals 4y plus 11. So it's going to be -16 plus 11. So x equals -5. So one thing you got to be careful of, because this is going to happen to us when we do solve with elimination sometimes. We might solve for y first and then get x. It doesn't matter what variable you solve for first. Whatever's easiest to solve for is basically the answer is what you're going to solve for first. Just make sure when you go to write your final answer, it's always x comma y. It doesn't matter what you solve for first. You just want to make sure that you always write your answer as x comma y. All right, and we can check our answers. So my first equation was -5x plus 4y equals 9. So it's going to be 25 minus 16 equals 9. So 9 equals 9. My second equation, x equals, whoops, I need to write that. So it's going to be -5 equals 4 times -4 plus 11. So -5 equals -16 plus 11. So -5 equals -5. So everything works out for us, so we're good to go. All right, so these are going to end up being the most difficult questions that we have when it comes to solving by substitution. We don't have any variable solve fors here. Like all those previous ones, we always had like an x equals something or a y equals something. This one we have nothing. So the easiest variable to solve for here is going to be y in the first equation. If I solve for x here, I'd have to do 1 divided by 3, 11 divided by 3. This is going from standard form to slope-intercept, by the way. Here I'd have to do like 5 divided by 7 or 7 divided by 5, 1 divided by 5 or 7. So we're going to solve for y up here. This is why we did the assignment last week on solving for a variable. It's one of those skills that just keeps coming back. So my new system is going to be y equals 3x minus 11. So this is my new system. Again, I just rearranged the first equation. So now I can take my y equals 3x minus 11, substitute that in right there. So I got negative 7x plus 5 times 3x minus 11 equals 1. So I got negative 7x plus 15x minus 55 equals 1. Like terms, add 55 to both sides. So I get 8x equals 56. Divide both sides by 8. Get x equals 7. So we got x, we still got to get y. We solved for y earlier. We said, y is equal to 3x minus 11. So that means y equals 3 times 7 minus 11. So that means y equals 21 minus 11. So y equals 10. So my final answer then is going to be 7, 10. And again, it never hurts to go back and check. We did a lot of algebra here, so it doesn't hurt to go back and check your answer in both the originals. Again, we rearranged some stuff, so I would just substitute back in the originals because those are the ones we didn't touch. We didn't try to rearrange them. So we got 3 times 7 minus 10 equals 11. So 21 minus 10 equals 11. So that's going to be 11 equals 11, so that's good. Negative 7x plus 5y equals 1. So I get negative 49 plus 50 equals 1, which is perfect. 1 equals 1. So we're good to go. Again, that's all we're looking for, is that these come out, our equations come out to be equal to each other. All right, last one then. Again, when you have to try and solve for a variable, this one's just plain old x. Okay, we got x plus 2y equals negative 1, 4x minus 4y equals 20. When we're trying to solve for a variable, the easiest thing is when it's just the coefficient of variable is just 1. So with x plus 2y equals negative 1, I can put a y there to show you where it's going to go. I can subtract 2y from both sides. So x equals negative 2y minus 1. So there's my new system. All I do is rearrange that first equation. I'm going to take this negative 2y minus 1 and put it in for x right there. Distributive property. So I get negative 12y minus 8 equals 20. So negative 12y. Just make sure we're good here, because we're going to end up with a fraction. So again, we got x equals negative 2y minus 1. So we got negative 8y. That should be minus 4. That'd be 24. So y equals negative 2. Now that's why you should always check your answer at the end. All right, so we got y equals negative 2, x equals negative 2y minus 1. So x equals 3. Just be careful, make sure you write it in order. So 3, negative 2, it's always x comma y. All right, and make sure, again, go back up, check your answers. You know, not that I'm a big fan of using calculators here, but if you do use your calculator, x plus 2y equals negative 1, so that means we have 3 plus 2 times negative 2. We got negative 1, so that's good. 4 times 3 minus 4 times negative 2. We get 20, so we're good to go.